So, good evening everyone, and welcome to the first edition of the Kaggle Days Meetup Brussels. So first of all, we're really grateful and we thank you very much because we're not expecting that much attendees for the first edition of this meetup. So thank you. So my name is Charles, I'm one of the organizers, and I work as a Google Cloud data scientist here in Brussels.
Yes, hello everyone. I'm Simon, a second organizer. So before diving into this meetup, I would like to thank McKinsey & Company, our host for the night. So a big thanks to them and for helping to create this data science community here in Belgium. So let me tell you how this works.
Switch it on the line.
On the line, yeah. Thanks. Okay, so let me explain you how this event was born. So Charles and I are two data science enthusiasts, and in May 2018 there was this event, Kaggle Days, that happened in Varsovie. Kaggle Days is a conference, the first official conference offline from Kaggle, and Charles and I decided to attend. We really liked the event, so we discussed with the organizer, Patricia and Maria, who are here with us tonight, and they will tell you a word later on. And we told them that we wanted to explore the concept in Belgium because we believe it's a great idea and we want to be part of the initiative. So Kaggle Days, actually it's a conference and there is two parts of the conference. The first part is talks given by Kaggle Grandmaster, and the second part it's an offline Kaggle hackathon. So a Kaggle competition that takes, it lasts for one day and we do teams within each other. So there will be these Kaggle Days happening in several cities of the world, and we are going to organize one in Brussels. It will happen in September 2019, and you already hear a sneak peek of the venue that where the event will take place. So now I will give the word to Charles, who's going to introduce you to the
Some of you
meetups.
that you might recognize, so that will be a digitizer, so data science community in Brussels. So aside from this 2 days format Kaggle Days, we noticed that there was a high demand for building local communities. So that's how the concept of Kaggle Days Meetups was born. So we are not the first to organize it. So in the last few months, I think there have been Warsaw, Madrid, London yesterday actually, and today so Brussels. So the concept is as follows. So we would do like 3 to 4 meetups every year here in Brussels. The meetup content, there will always be a talk from a Kaggle Grandmaster and one talk from a knowledgeable data scientist practitioner. So the topics will be from intermediate to advanced topics. And the next meetup that we plan to organize will be like mid-February, and for this meetup we plan like more to deep dive into a Kaggle competition.
Yeah, so now please welcome on stage Patricia and Maria from Logica, the organizer of Kaggle Days.
Okay, so I would like to say hello, and maybe it will be a very short speech, okay, because we are waiting for somebody else, and you probably don't know who we are, do you? Some of you know. Some of you know. I met some of you. Okay, so maybe I introduce ourselves, but first of all, I would like to thank you for inviting us here and for doing this Kaggle Days. So those claps should be for the organizers, for them. So actually, could you raise your hands and thank them for organizing Kaggle Days here in Brussels? Actually, we met in Warsaw, but this part of the story you will hear in a minute. But first, I will start with a presentation. My name is Maria, and this is Patricia. We are from Logica, as you can see. It's on my back. It's here, and we are a company of crazy people. Seriously, crazy data scientists who decided that Kaggle is the ultimate way of learning. And we decided that people can learn online. They can do wonderful stuff. They can team up. They can even admire themselves and know them from their code, right? But they don't know each other in person. And that's why we decided that we need offline community for people like you, to give them opportunity to meet and to meet with the best people in the world, like the grandmasters and masters. Pavel, who is a co-founder of our company, he's also a grandmaster, and that's why we came up with this idea, crazy idea of Kaggle Days in Warsaw. And Kaggle said yes, and we created this first event, and it was an enormous success. So people said yes to Kaggle Days, to offline community, and to learning through Kaggle. And that's how this Kaggle Days was created. So now it's a wonderful success, because in 2019 what we want to do is we want to open at least 20 up to 25 new meetups all around the world, already in 3 different continents. But we won't be organizing just Kaggle Days meetups. We will be organizing like 3 or 4 times a year. We will be organizing special conferences for you to meet. It will be bigger conferences, like 2 days. On the first day, there will be presentations and workshops done by the grandmasters and masters, and on the second day, there will be a specially designed competition, 11-hour hackathon on Kaggle. And of course, the winners will get recognition and also prizes, other stuff. So, how do you like the idea?
Good.
Good. Okay. Good. Okay. So, I would like to invite you to Paris. Oh, thank you.
You're welcome.
I like it. So, I would like to invite you to Paris because the next event will happen there in January on 25th and 26th of January. The number of spots is limited. We have only 200 spots, and not all applicants will be admitted. So there will be a registration process. The ticket price is very low because it will be like 150 euros per person, and will be sponsored by our wonderful sponsors. And we plan a couple of surprises for you. You will be able to meet at least 10 grandmasters and to learn from them, of course, and to win a competition. So, please feel invited. The registration should start tomorrow, actually. Okay, so what else, Patricia?
So yeah, I'll just briefly introduce our 2 goals with the community we're trying to create. So, so that you know, because Kaggle is a great platform for data scientists, as you probably know. It's a great place to learn, but we noticed that there are not enough offline events where people can meet and actually team up and to work together on the problems and on the competitions. So the goal is to create data science community, Kaggle community offline through Kaggle Days, to create the consistent net of events, and so that you could all participate in those competitions together, to learn from each other and inspire each other and have fun together. Actually, the first Kaggle Days was so much fun that we opened already 5 meetups in all over Europe. And we're opening, just like Maria said, a few more next year, early next year. So feel invited to all of them. If you travel somewhere, probably will be there next year.
But if you want to open them in your own city or in your country. So how about community? Because you create this community. So please remember one thing from what we said, except for Paris, of course. What I want to say, that this is your community. This is created for you, especially for you. Alberto came here for you. Charles and Simon did it for you. So please do ask questions, be active, come for the next meetups, suggest something, because you will be creating this. Follow us on each of those, Instagram, Twitters. We are everywhere, at least we will be. So just contact us, because we are like you. So we create this community together. Please remember this and just enjoy.
Thank you.
Thank you.
Myself and Simon can only recommend you to register for Paris. It's close by, and it's super fun. We attend a lot of meetups and conferences in general, and we never attended in such a short amount of time so many interesting workshops. There were like more than 10 Kaggle Grandmasters giving very hands-on workshops.
Yeah, and about that, you can go on YouTube to Kaggle Days channel. We have conferences from the first edition. From the first edition. So, for example, there is an expert in chatbots. He explained like how to build your own chatbots, but for example, how to train your neural net to do typos fix. Then you can better train your model. So,
Yeah,
but
so
now back to today.
Yeah, so the agenda for tonight. So you have the
You want
slide with the agenda?
Yeah.
Yeah, okay. So we'll start with the talk from the Grandmaster. So tonight we are really grateful to have Alberto here. So Alberto comes from Milan just for this event. And you also visited Brussels. So yeah, Alberto is the number one Kaggler in Italy and top 100 worldwide. So it's really an honor to have him tonight. Then we'll have the talk from Denise Ducrot. So Denise is an associate partner at McKinsey. So he has advanced expertise into advanced analytics applied to the manufacturing industry. And he will give us through a use case a talk on how McKinsey tackles analytics problem and also the methodology that they use. And that's it.
Yeah, and then we will go to the 23rd floor to have a dinner together. So just before to start, I would like to ask you to please take your cans and stuff like that in the trash after the conferences. And now, without any further waiting, I would like to welcome Alberto Danese.
Okay, good evening everyone. It's really a pleasure for me to be here in Brussels tonight for the first Kaggle Days Meetup here. And my name is Alberto Danese, and I will give a talk about Kaggle and why it matters for the data scientist, why it is a platform and also a community of data scientists that it's worth knowing and it is worth joining, in my opinion. So, a few words about myself. I'm a senior data scientist in Cerved. Cerved is the leading credit rating agency in Italy, leading information data provider, and we basically provide a wide range of services on credit, so from credit origination, lead generation services to credit management. So we are basically a data-driven company because we work with data and algorithms. And we're quite a large company too because we are more than 2,000 people. I work in the innovation and data sources team, and before joining Cerved, I was a manager at Ernst & Young, and well, I graduated a few years ago as a computer engineer in Milan at Politecnico. My passions actually are everything that stays at the crossroads of, let's say, technology, IT, on one end, statistics and applied mathematics on the other, and business, of course. And I think that machine learning really fits in this definition. But blockchain as well, the crypto world is something that I find really interesting for me. And well, obviously Kaggle, as Simone and Charles mentioned before, I'm the first Kaggle in Italy, and I think I learned a lot with this platform. So I would like to do just a quick poll to understand what is your knowledge about Kaggle. So I think, I mean, I'm a data scientist. I would like to cluster you in 4 groups. The first cluster is those who are curious, just curious about Kaggle. The second is those who are registered and maybe played just a bit. The third one is the active Kagglers that do compete in real-world competitions. And the fourth one are the addicted ones. So, who belongs to the first cluster? The curious ones. Don't be shy, raise your hand. Okay, just a few, okay. Who is registered? Okay, most of you. Who is an active competitor? I would say around 10 of you, okay. Who is addicted? 2 of you over there and me, okay, 3 of us. Okay, good to know. What is Kaggle? Kaggle is basically the leading machine learning competition platform since 2010, so it's been 8 years that is on the market. And basically, you can see Kaggle as a marketplace where there are companies that publish data and problems that can be solved with machine learning, with artificial intelligence. I say with some kind of magic, of quantitative magic, let's say. And so the company is on one end. On the other end, you have data scientists. Data scientists that compete to build the best algorithms using cutting-edge technology. And Kaggle has been acquired last year by Google, and after being acquired, it's grown into a fully featured machine learning platform because it has learning modules that are Kaggle Learn, and in my opinion, they are very good. There are code sharing features, so you can share snippets of code or also complete solutions to Kaggle problems. There is a job board and much more. So the real question is, why should you care? Because I think that most data scientists are curious. So maybe you can have your own project that you want to work on, and it's cool. Maybe you want to contribute to a project on GitLab, on GitHub, and it's cool too. So why Kaggle? What is the reason? What are the reasons why I find Kaggle interesting? Actually, there's a ton. There are tons. First of all, the sponsors, because when you participate to a Kaggle competition, you participate to a competition sponsored by this kind of companies. So you can find the tech giants, you can find also banks, insurances, research centers, pharmaceutical companies, for instance. So really, you're working with some of the top companies around the world. And for me, it's important to understand that I'm working on something real and something really important for these companies. So the sponsors is one of the important things. And then you have prizes. This is often overlooked because maybe it's not easy to realize also the amount of prizes that are in these competitions. Because last year there have been more than $4 million awarded to data scientists. That is quite a lot in my opinion. And Kaggle does pay, actually. And okay, if you don't care about money, maybe there are some competitions that are recruiting competitions. So Facebook did 5 recruiting competitions, not just one. Actually, Facebook is doing no more recruiting competition after the acquisition from Google. Kind of obvious. But also Walmart and other great companies. And I mean, it's not about the money or about the jobs, but I put myself in the shoes of these enterprises. These enterprises have to define competition, and it's not so straightforward, because not everything is inherently a competition on Kaggle. So you have to define a problem, you have to collect the data. Some companies are more mature, some are less mature. So it's a work to prepare a competition. You have to anonymize data because you are publishing data, so you have to be careful with what you're sharing. And you have also to persuade the legal and business departments that you're going to share your valuable assets. I think from an enterprise point of view, this is one of the most challenging part of hosting a competition in Kaggle. So if despite all these issues, let's say, they are still hosting competitions on Kaggle, probably they are solving real problems and they are happy with the solution that they are getting from Kagglers all over the world. And when I think of the companies that do recruitment competitions, there are companies like Facebook, like Walmart. I think they are already very attractive. I don't know how many resumes Facebook receives every day, but still they are doing this kind of competition. So I think they are also finding some talents on Kaggle. So you have the important sponsor, important prices. And this is the other important aspect, data and problems, because I think that you recognize something here. Okay? Maybe some of you recognize this flower. Iris, obviously. I can classify it just by seeing it. And this is the famous dataset of badly handwritten digits that is used in every tutorial all over the world. Actually, I got tired after doing a lot of tutorials with this data, because I think that this is not machine learning. This is a toy. These are toy data sets, and I want to apply. I want to apply machine learning to real world problems. I really got bored using these data sets. And okay, besides this, we have also some interesting participants. Do you recognize this guy? No one. François Choyer. François Choyer. Who is François Choyer? He's the author of Keras. I think most of you have used Keras as that is one of the leading deep learning frameworks. And this other guy, I think it's more challenging to name him, but he's Tianqi Chen. Tianqi Chen, I think he's amazing data science actually, because he's the author of XGBoost and one of the co-authors of MixNet. And both of them have used Kaggle. And I think it's very important that they use Kaggle to show that their frameworks are effective. So, I mean, winning algorithms from Kaggle are becoming standards in the industry because I think that everyone knows XGBoost, everyone knows Keras in the data science world, let's say. So they prove the effectiveness of their algorithms on public data. And besides these participants, you also have a large community of Kagglers, a large online community of Kagglers, let's say. Almost 100,000 participants that are ranked, okay, 50 years from novice to grandmaster. And all these Kagglers share a common passion for data and algorithms. And they can prove their skills on real-world problems and real-world data. You can see, just for curiosity, a distribution of grandmasters around the countries in the world. You see that most of the grandmasters are in the US, but actually I think that most of them are not Americans, because most are simply it was not meant to be a joke. It was not meant to be funny, but it's just a fact that most of the Kagglers from US are resident in the US, but are not originally Americans. And then you can see my profile. You can see also here this competition that I decided to hide, and I'll tell you later why I decided to hide this. So really, we have seen several aspects that make the Kaggle a great platform, from participants, community, problems, sponsor, prizes. I think there is almost everything. So, how does Kaggle work? Basically, Kaggle requires a sponsor, a company, to create, first of all, a labeled dataset. So basically, you can imagine a labeled dataset as a large Excel, for instance. Large Excel with a lot of columns, a lot of features, and a final column that is the target column. That is what you want to predict. So it's kind of a simple problem. In this example, I'm showing you a table, but it could be a list of images, for instance. So you can have, instead of features, you can have pixels, or you can have text, free text. But basically, the important thing is to define a supervised learning scenario. That is having a target, having the definition of something that we want to predict. And so this is the first step from a company point of view. Okay, after collecting this data and building a large table, actually the company has to divide the data set into two parts, a training set and a test set. And this is really the smart choice of Kaggle, because the training set gets published with all the features and the target, while the test set gets published only with the features. So the target of the test set is kept private, and it's never published. So basically, I think you get how Kaggle actually works, because Kagglers are asked to predict the test set, and the performance is evaluated according to some predefined metrics. So it's easy to do a ranking of the top solutions. I think it's kind of straightforward. And usually, I stop here when I explain Kaggles to non-data scientists. Actually, there is something more. First of all, when a Kaggler submits a solution, and some of you already perfectly know this fact, you get immediately a score of your solution. But the score of your solution is not done on the entire test set. It's done only on a fraction of the test set. Typically, the first 20 or 30% of the rows of the test set. So you have an immediate feeling of how you are performing. You have, for instance, an area under the rock curve prediction evaluation, let's say. but it is just on a small percentage of the test set. So basically, what's the point? Is that submitting every day a new solution, you can easily overfit the so-called public leaderboard. So these 20 to 30% of the record. Because every day you submit up to 5 solutions, and you start to model not the problem itself, but also the noise, let's say. But when the competition finishes, typically after 60 to 90 days, the score is not done on the 20 to 30% that belongs to the public leaderboard. It's done on the other part, on the remaining 70 to 80% of the test set. So basically, when a competition finishes, you can have a shake-up in the leaderboard, because those who actually built an effective model, a robust model, that generalizes well, gets to the top of the leaderboard, while those who overfitted the public leaderboard fall behind in the competition. And actually, the private leaderboard is the only one that matters, and prizes are awarded on the private leaderboard, obviously. I forgot to say one thing, that is that when you submit a solution, typically, always you submit only the prediction themselves. So you submit typically an ID and an estimation. You do not submit your code. You have to submit your code only when you finish in the top 3 or whatever the number of the winners. Because winners are required to submit the full code that has to be reproducible. So you have to keep in mind when you build a model on Kaggle that you have to ensure that everything can be reproduced from top to bottom, let's say, from A to Z. And you can see another thing in this image is that you can, let's say, compete alone, like those guys that are alone, or you can compete in large teams, let's say 5 people, 4 people. So basically, you can decide if you want to compete alone or to merge with some other. Okay, I will just show you some example of competitions and then tell you something about how I personally approach a competition. Competition can be broadly classified in 3 large families. Classic machine learning competition that are tabular data, like a large Excel, let's say, or maybe there can be more tables that have to be joined together, but let's say it is classical machine learning. Then you have computer vision tasks that can be, for instance, related to images, but also to videos, to movie pictures, let's say. And the third cluster is that of natural language processing. So I will show you in a while some examples to better understand what it means. And competitions can be public. Most of them are actually public, more than 95% of them. So anyone can join, or private. And the competition that I decided to hide before was a private competition. So the sponsor decides to publish the data only to a subset of users of Kaggle, typically masters and grandmasters, because they want to be sure that the data doesn't get spread to too many people, let's say. So some examples of the different competitions. This was kind of a crazy competition for me. It was a competition by the largest mobile advertisement provider in China. And they have a serious problem, that is fraud prevention. Because there are click farms, they call them click farms. They are like these large places where there are hundreds of thousands of SIM and tens of thousands of mobile phones, and people just click on advertisement to generate fake clicks, and there is a large market on this topic. So basically a developer can buy, let's say, 1 million clicks on his app to have his application on top of the most downloaded application. And it's kind of crazy. I knew nothing about this world before joining this competition. And it was really an impressive competition, also for the for the amount of data, because this company in 3 days collects 180 million clicks. So it's really a large amount of clicks. And basically, you had to train your model on 3 days of clicks and predict on the next day which clicks were fraudulent and which clicks were real. So this is, I mean, kind of an interesting competition for me, but it's actually a regular machine learning competition. Everything is tabular data. You have also computer vision competitions, and I switched from fraud detection to a much, let's say, much more relevant topic, that is the analysis of medical data. And this was an important competition with a large prize, $1 million, by this foundation. And this competition was about analyzing images, I think they're called TACs, TACs, images of the body of patients. And the objective was to understand if these images were the images of lungs with cancer, let's say. So it's a case of data science for public good, for sure. And it is an example of the competitions of computer vision. And okay, NLP, natural language processing, this was another interesting competition by Jigsaw and Google. The objective was to classify toxic comments, because in the forums you can read everything, and you had to classify comments based on their level of toxicity, let's say. So you have to classify offensive comments, discriminatory comments, obscene comments, and also level of obscenity, let's say. So it is basically, for this situation, the data was free text to analyze, and you had a ton of data to classify automatically. Last example, this is a challenge that I joined recently, an amazing one. I had decided not to join a competition in Kaggle for a while, just to take a break. But I saw this competition and I had to register. I couldn't help. And this competition is about classifying, let's say, supernovae, stars, and other luminous objects in the sky. The data is tabular data. They are not images. It's tabular data that comes from telescopes, basically. So you have in this in this competition, you have light curves. Light curves, are time series of the fluxes of different bodies in the different stars, different supernovae. So this is a classification problem, and it's kind of an amazing one. This is sponsored by the Natural Science Foundation in the United States. So what is my approach? My approach, well, first of all, I try to find a motivating competition, because I know that it's going to take a lot of my time. So I usually try to understand if the competition can be interesting, maybe also from a professional point of view, because some competitions, maybe those in the credit sector for me, can be useful, because I get to see data from other companies, and I understand problems that other companies similar to the company where I work have. So these are competitions that are interesting for professional reasons, and some other for personal reasons, because maybe I can understand new techniques, new ways to approach machine learning problems. Then I try to understand the business problem that is behind this competition. And I work on my own for a while. I do some exploratory data analysis, so I try to understand the data in the training set, in the test set. I define a validation framework to understand how to build a model and how not to overfit the training data. And I build a baseline model, so maybe a model that runs in a few minutes and helps me in defining a baseline performance. That becomes my reference. And then I consider joining forces and creating a team, because as I told you before, you can join a competition and go solo, work alone until the end, or you can join forces with other teams. And actually, I always met brilliant people on Kaggle. I did one competition with 3 Chinese guys, And it was funny because one of them was in Shanghai, one actually was studying in Kansas City, and the other was in San Francisco. So I was in Milan, and we worked basically 24/7 as a team. And well, when you work in a team, you really understand that for the same problem, different people have different approaches. So different approaches, maybe different tools, different libraries. Usually you have a best final ranking because you know, many minds working together usually help in getting a good final ranking. But obviously there are also some cons because working in a team, especially if the team is large, takes time just for coordination. And you are not forced to deal with those things that you do not like a lot. When you work alone, you have to do everything, from the exploratory data analysis to the reproducible environment, to the validation framework, to the final prediction. And so, I mean, you learn a lot in both situations, if you work alone or if you work in a team. And then you try not to overfit the leaderboard, because that's the whole point. You have to build a model that is robust, that generalizes well, not a model that just fits the training set. And so I give you just a quick hint. As you saw, this presentation is not definitely not a technical one, but just a hint on how not to overfit the leaderboard. Usually the test set and the training set are not similar. They have some differences. And well, a classic approach, a classic statistical approach would be to analyze the different features, perform statistical tests on each feature, understand the distribution of this feature, and do this kind of stuff on maybe hundreds or thousands of features, and it will take really a lot of time. What they do to understand if training set and test set can be comparable, let's say, is creating a different machine learning problem from the original one. So I basically dropped the real target that is present only on the test set, and I create a meta problem of machine learning. So I add a new target where I put one for the records belonging to the training set, and I put 0 for the record belonging to the test set. So basically, my problem switches from the original problem to a binary classification problem whose objective is understanding if I can tell training set and test set apart. So basically, I train a simple model, maybe an XGBoost, a LightGBM, a tree-based model, and I see what are the important features that makes train and test distinguishable. So I focus on this feature. And it saves me really a lot of time, because you cannot go on thousands of features and study them individually. So I try to answer the question if the test is distinguishable from the training set. And this is just a simple example of some smart things that you can do with Kaggle data. So, okay, I told you why I think Kaggle is important. I showed you some example. I gave you a quick hint. I would just like to introduce this topic. I think that the following speaker will speak more about this. So what is the difference between Kaggle and a real world as a data scientist? Well, Kaggle competition usually have no constraints, so you can build extremely complex models that maybe takes days to train, and that achieve just a small percentage of improvement on a specific metric, and it is fine, it is perfectly fine. In a real-world environment, in my day job, for instance, I have constraints. Constraints are also on clean code, on several aspects of an enterprise. And then in Kaggle, you have a test set that you want to predict, and you already know the test set that you are going to predict. In the real world, maybe you are predicting something in the future, so you don't have a test set to predict. So this is just an example of some of the differences between Kaggle and the real world. But actually, the differences are much larger, in my opinion, because Kaggle is a pure objective algorithmic competition. So you focus on machine learning most of the time and understanding the data. But in the real world, it's a bit different, because first of all, you have to define a business problem, a data product, together with marketing structures, marketing offices, let's say, in your company. you have to find the right data. You have to collect data to gather data. And then, okay, you can do the machine learning and stuff. This is similar to Kaggle. But in the end, you have also to define, to engineer the solution, to put it in production, let's say. You don't want a script to run, you want to enforce some constraints also on the efficiency of the code and such. And you have to maintain this solution. So basically, Kaggle focuses, from my point of view, on the central part of this problem. So someone else has already collected the data, someone else has defined the problem, and someone else will eventually implement your solution in a production environment. So they are two different problems. Just a few more things. Data comes first. This is an important thing, and I think many data scientists, especially junior data scientists, underestimate this fact. I would choose any day an average model and great data, high quality data, over a great model and low quality data, average data. So first of all, you have to collect data and then collect high quality data, and then you can build machine learning on top of this. This is a really important problem in the enterprise. And there are other things like explainability, for instance. This is a topic that is very interesting from my point of view, because usually models on Kaggle are gradient boosted trees or deep learning models, neural networks. They are not easily explainable, but there is a lot of research on explainability, and this is an important topic in the industry, because you have to explain the model, and you cannot accept a complete black box. But then you have you have something in common also between the enterprise and Kaggle, and for instance, the validation setup. Kaggle enforces you to follow a validation setup that is define the metric to evaluate your model, and this is important also in the enterprise. What is my toolkit? Well, I prefer R over Python. I think that nowadays many data scientists prefer Python, but it's a matter of choice. I think that they are exchangeable for most things. I think R, Studio, and Git are a classical stack that I use every day, and these are some of the libraries that I use during my competition and also during my work. I will leave the slides so you can check them out later, maybe. So, wrapping everything up, is Kaggle worth your time? This is an important question. I will just show you a couple of slides. This is my personal experience, so I leave you to understand if Kaggle is for you or Kaggle is not for you, if it's worth your time. Well, I graduated in 2007, and I started working in IT security, so nothing to do with data. But I got a bit tired of that field, and in 2014 I found Kaggle.com. I saw this platform. I thought it was really cool, and I still think it's really cool, but I didn't know where to start. I mean, I had some experiences with databases and with algorithms, but not so much. So in 2015, I decided to dedicate myself 100% to data science. I took a part-time master, but there are many other ways to understand data science. There are online courses, there are many things that you can do. And actually, in this master, I had to do a final project, and I decided to do a Kaggle competition as final project. And it was my first Kaggle competition. It was quite an interesting one, quite a nice finish, almost in the top 1%. And it was just the first competition, because after that I did the competition with the Chinese guys that I mentioned before. I joined Sherbet, the Italian data company, and I did other competition in the next few months. So I did a lot of other competition, and I learned a lot every day. And in 2008, well, money, it's nice, because I won quite a large prize in a private competition. And when you win a competition or you rank in the first 3 position, you have to do also a winner call. So you basically have to explain to the usually head of data science of the sponsor company what is your model, what are the choices that you did, and you explain everything about your solution. And then I entered the Grandmaster tier, and I'm still learning today a lot with new competitions. So conclusion, last slide. I think that the only cons of Kaggle is time, because competing takes a lot of time. There are many motivated Kagglers, prices are interesting. If you compete alone, it can be difficult to achieve a top position. But this is the only cons, the only negative thing that I can think of. On the other hand, I think there are countless pros in Kaggle. There is no better place to learn machine learning, for sure, because you have real data, real problems. You can also have a portfolio of problems that you have solved, for instance. It's very important for a data scientist. You understand the tools that really work, because there is a lot of hype on machine learning, artificial intelligence, data science, call it the way you want. So you can understand if a library, a tool is really working or not. You can understand this important thing. You understand what it means to build a robust solution, a generalizable solution. You understand the concept of overfitting against robustness. This is key in Kaggle. And you develop skills that are usable at work. You enter in a nice community. You also make a little bit of personal branding that doesn't hurt. So in my opinion, there are really a lot of reasons to join Kaggle, and hopefully some of you will join in the next days. So thank you very much, and happy Kaggle.
Thank you, Alberto.
Thank you. So we have time for
questions.
So yeah, some questions.
How many hours do you spend
On a competition.
by week? Yes, on average?
I think that on a competition I usually spend, let's say, 80 to 100 hours. A competition lasts 2 months to 3 months, so it's around 10 hours a week, maybe. It's a lot, but it's not crazy. I mean, I think it's worth it.
I feel like a lot of these competitions require a lot of domain-specific knowledge. How much do you usually know about a competition before diving in?
This is really an interesting question. So I repeat for the others. So the question was about domain knowledge. If domain knowledge is important and how much it is important. I think that it can be important. I just give you a few examples. There are competitions where data is completely anonymized. And I mean, it doesn't mean that there is no name of someone or something. It means that the features are, let's say, are called variable number 1, variable number 2, variable number 3, and really you know nothing about data. And you can still build effective models. So in that situation, you cannot add any domain knowledge. Personally, I prefer competition where where features are at least named, so I can add some domain-specific knowledge. And for instance, the last competition that I finished was the home credit one. So it was about credit origination, let's say, estimating credit default in the origination phase. And I did this competition with a guy, really brilliant guy, Carlos Brioso, that is head of actuary in a large US insurance, if I'm not mistaken. And I mean, adding domain knowledge really helped, because there are specific functions for dealing with credit data, and I think it can be important. Please.
So I have a question about collaborating. So you gave example of a team with the 3 Chinese Chinese guys. Actually, 2 questions. How did you find them? And second, how did you go about collaborating and sharing tasks and responsibilities?
Oh, okay, good question. Actually, it was one of these guys that found me. Okay, Yu Yang, this guy, and he's a student, a PhD student in Kansas City, and you know, we were around the same position on the leaderboard. I probably had an higher ranking or something, but he was looking for a mate, for a teammate. And so we created, well, we had already worked alone for a few weeks, and we created a team of 2 people. Then after this, after creating this team, we decided to add another participant and then another one, and we finished with 4 people. So basically, you look around, maybe someone, you have met someone in person or another competition. It's really up to you. And when it comes to collaborating, we had a large Trello board. I don't know if you use Trello, okay? So basically, we kept separate code bases, and we built a large ensemble of our models. Actually, we stacked our models. This is a choice that is not trivial, because you can decide to merge the code bases or to keep code bases separate. I think that it's complicated to merge code bases, especially when you work in different places all over the world. But it's really up to you.
So, then, summarize, then each of you did still go through the entire workflow.
Yes, but we share the code bases, so I could see everything that the other guys did, so I could take some parts and.
Thanks.
Do you prefer to find your one specific model, or do you prefer to stack multiple different models on top of each other?
I typically work on a strong single model, because in my opinion, in most Kaggle competition, feature engineering is key, and then you can earn a little bit more by stacking models, but you don't finish in the top 1% just by stacking models, let's say.
What is your baseline model that you use?
Well, I would say that for tabular data, the state of the art is currently LightGBM, maybe XGBoost, but LightGBM. And for computer vision you have several neural networks, let's say deep learning frameworks that you can use. But I work mostly on tabular data, and I would say that nowadays gradient boosted trees like LightGBM, XGBoost, or CatBoost tend to overperform deep learning frameworks. They are also faster to train, and several advantages. Please.
Okay, talking about like boosting these kind of models, have you ever used these models in your job?
Okay, this is an interesting question, because there are sectors that are regulated. So when you have a regulated sector, some models are not easily, let's say, acceptable. But yes, I have used some of them. It depends on the field. Sometimes you have to work on classical statistic models because there is a strong regulation. And in other situations, you can use basically any model as long as it performs well. So that's why I mentioned the explainability topic before, because in my opinion, the research on explainability is key for the evolution of machine learning, because on Kaggle you can find amazing solutions, but in some sectors they are not acceptable if they are not explainable. So there is a lot of research on this topic.
Question about the percentage of your own code versus the reused code that you did, for example, for the competition you did more.
I have not understood the question. The percentage of my code?
Yes, your own written code versus reused.
Reused. Okay. This is another important topic, because for those who don't know, on Kaggle you can share code with the kernels. Kernels are basically snippets of code, but they can be also full solutions, and they are public. They are freely available, freely downloadable, and basically you can take all or a part of, or just some line of codes from public kernels and merge them in your own solution. So it really depends. For instance, in the private competition that I did beginning of this year, there were no kernels available. So it was everything my code, because in private competition there are no kernels, at least in that competition. Usually I take a look at kernels, and usually I do not use kernels as they are. I take some, ideas from the kernels. That's.
How pleased are the organizers
when they see the results?
How pleased are the organizers?
Because I could imagine that the guy, the head of science, would say, yes, that's something I still thought about, but my guys didn't have time to do it, for example. So
Yes.
how pleased are they from your point of view?
I think, well, it really depends, but some of them are really happy about the results. I suggest you to read the comments on Zillow competition. Zillow competition was one of the has been one of the most famous competition on Kaggle because it awarded, I think, $1,200,000, so a large amount of money. And the head of data science of Zillow wrote a blog post on their own blog about how they integrated the solution from Kaggle on their own models. So I think he was really happy about the results. I don't know if everyone is happy about the results because on one end, I mean, if a Kaggler achieves a much better solution than your own team, it can be difficult to justify.
Yeah. Okay. Can you share some tips on feature engineering?
Oh, it's difficult to do it in a few minutes. I would just say that on Kaggle you have to be very careful about the differences between training set and test set. You can rebalance the training set. You have to. This is the basic of machine learning. When you feed some data to a machine learning algorithm, the algorithm learns this data. But if the test set is different, it will not perform well. And this is particularly important, for instance, for time variant competitions, where you try to predict something that changes over time, like the competition where I actually won the prize. Not easy to address this question in a few minutes. Maybe we can talk about it later.
I have one last question. So you said Kaggle does pay, but you haven't left your job yet. So I was wondering, does it pay to be able to do it as a full-time job, or is it?
I think it's kind of difficult because you know there is a lot of competition on Kaggle and a lot of really amazing Kagglers. Typically on Kaggle there are a few competitions with large prizes. Last year there have been 3 competitions over $1 million prize, and then a lot of competition with prizes from, let's say, $20,000 to $100,000. And then if you participate in a team, you have to split obviously the prize. And so it's kind of difficult. But I think I find it interesting to learn on Kaggle new things. For instance, I'm participating in the plastic challenge that is about time series. I'm no expert on time series, and I'm taking a look at kernels, some brilliant guys that write public code, and so it's nice to understand from Kaggle and then apply some of the things that you understood in a Kaggle competition to your job.
Okay, thank you, Alberto.